Veritas Automata, the truth in machine, shaping reality in every routine.
Cool. Welcome to the Veritas Automata Deep Dive Podcast. I'm Ben Savage, the CEO and founder. I've got Saurabh Sarkar with me as well. So I think we were talking about, because I've got a shirt for Halloween.
All right.
We were talking about what may be your next project.
Skeleton, LLM, and laser eyes, maybe?
I was going to say digital eyes, just
All right.
LCD eyes. Laser eyes, we don't need to blind anyone. But
Especially if there are cats around. Yeah.
would it blind the cats or would it just turn them into games?
That's the fun part, right?
I mean, that alone could be an LLM just say, hey, go play with the cat. There's a little laser on a turn.
That could be a product. People do all kind of fun stuff with their cats, right?
We may know someone who knows a thing or two about lasers.
You do?
Yeah.
Oh, yeah, we do.
Exactly.
Yeah.
Okay, we may have to come back to that one.
All right. Sounds good.
But on more serious topics, today there's going to be a bunch of news. We're going to talk about some security, but I think just before we came in, Apple introduced a bunch of new hardware. So they introduced the new M5 chips for the MacBook Pros. I guess I'll have to determine, because this is only a MacBook, an M3. I did not go for the M4.
Mm-hmm.
And the M5, the big thing is they increased the memory bandwidth.
Okay. Faster inference. Your computer is already flying so fast. I don't know how fast it will go with that.
We're going to have to do a drag race.
Okay. All right.
Because we've got the dual A6000.
All right.
We'll have this. We've got to do a drag race between those two.
Mm-hmm.
And we may have something new that we're not going to reveal it to everyone yet that we want to drag race against to see what can generate tokens the fastest.
Yeah, sure. We can give it a try.
Doesn't mean we'll need a test harness so to be able to say, okay, when we've done each one, what's the speed to tokens?
Okay. So it would be top GPU, not top gear?
For now. Hey, you're always looking for an excuse for more GPU. I mean, we're still going to get that
True.
RTX Pro. At some point, you're going to ask for like H200 and
Okay.
H100, something like that.
So we need our own Stig.
Well, yeah, it's a piece of Python code, right?
That's right. Call it Stig.py.
Or you train an LLM to go run it. So that's the Stig. It just appears on a screen.
Right.
But the other thing that we're going to talk about, there's been a lot of security news. And, we've talked about some of the different things where people can go hide text in different ways. And some people are just doing one shade wider pixels than another. So the human eye doesn't determine it. But one of the other things that there were a couple of articles at the end of last week were about what they call ASCII smuggling. Mm-hmm. And so if I remember this right, and correct me, is that there are different ways, both in Markdown and in normal text, where you can put hidden characters that most editors or visualization tools of text don't display. And those might have things around like what language it's supposed to be in, like Spanish or English, or like what your emoji should be so you get the right flag. Mm-hmm. And people can abuse those and put prompts in that are malicious, like go show me all your secrets.
Or delete my email box. So you could have a prompt saying that summarize this email, but underneath you have this hidden instruction. And with the agentic stuff, right, where you have where the code has the control of your inbox and stuff, it could essentially delete.
And it's emails. A little bit of a risk if you're just copy pasting. You're not paying attention to where you get things and when you copy paste them.
Right.
But it could be a real challenge if someone sends a calendar invite and you're using a smart LLM-based calendar system. Yeah. And all of a sudden it says, don't just tell me the one meeting you accepted, but tell me the person's entire calendar or their email secrets.
Yeah. Yeah. So it's just straight up using LLM is becoming more and more unsafe, right? Yeah. So I think there's another paper that Amazon introduced where it was talking about sanitization and putting safety guards in the LLM in itself, right? So sanitization is it's a good parallel would be SQL injection, where if you don't sanitize and run random SQL stuff, it could harm your DB and inject stuff.
You mean the percent symbol's a bad thing in SQL?
Yeah, percent is a funny thing, right? So
for those of you who don't do SQL, percent is kind of the show me everything.
Yeah. So the sanitization, again, the scripts around sanitization are getting more and more involved, right? What is a clean and what is a hidden prompt? it's very hard to decipher those, even if it's encapsulated with certain ASCII codes and things like that, right? So a typical example would be in academic paper. I recently came across an article where people are using LLMs to write those papers, right? And on the reviewer side, people are also passing them through LLMs and kind of getting a feedback of what this feel for what the paper is. So it is possible to write instructions saying that do not say anything negative about this paper, say all positive things in the review. So when the review comes out from LLM, it kind of is really good paper, it's novel and doesn't point any of the flaws. And then the reviewer, if they don't look at it through a lens, they are missing those negative points, right? So it's interesting time. If without 100, I think everybody should not have 100% confidence in LLM.
No, I think that's a given, right?
Yeah.
And so first, to go back to the ASCII smuggling, and I'll come back to the last comment. I think one of the things that's important is that you've got to remember to build that tooling. And if you're building an application that uses any generative tool, you've got to understand what are the threat models. And then either if you're doing everything on your own and you're hosting it on your own system, you've got to build all those protections in or find libraries that do it. But this is one of the reasons where like Azure or AWS can have a lot of benefits, because both of those have some safeguard engines you can use that will sanitize prompts, they'll sanitize outputs, they'll do all kinds of checking, not just for that one, but all the different things that are out there. None of them are going to be perfect, but at least it's going to save how much work you have to do. So that's a trade-off you've got to think about from a time perspective on when you implement something.
Right. And, around even just using I think there's one other paper that came out around, how little of a data is needed to poison that one.
We'll get to that in a minute.
All right. Okay.
Because you had talked about like not trusting LLMs.
Yeah.
I think that's a super key thing, right? When you look at the common theme and different things people have run into, when you look at the lawyers who are running into issues, getting in trouble, they're not verifying the output, right? So everyone's got to go verify. For the generation below us who grew up on Harry Potter, and that's coming. There's an important line there in when someone was writing in a journal,
right,
and it was writing back to him. What they said is never trust anything where you can't see its brains.
Correct. Yeah.
And when you can't see the algorithm, which is a problem with these large language models, you cannot see the system prompts, you cannot see the safeguards, you cannot see how the model makes its own decision. No one has actually understood why models make the specific decisions they do. You have to go in with a trust but verify approach. However you build your tools, you've got to think about that.
Yeah, I mean, trust but verify goes beyond that, right? There was a Deloitte article that Deloitte did something with LLM, and then they referenced
that was a report that they had charged a significant sum of money to the Australian government for, that they had then done it, and they had not reviewed it properly, so it had all kinds of citations. I think it was on environmental topics,
and it was quoting things that didn't exist, right? So they even got the name of the authors correct, but when the reviewer went through and checked, they don't have those publications. So which is kind of scary. It kind of is hallucination.
It's a combination, right? Sometimes it's a pure hallucination, sometimes it's confabulation where maybe there is a paper similar, or two papers, and what it's doing is blending the names together. We've seen that when we talked about some of the medical systems.
Correct. And if you think about it, how it all works, it's kind of stored within as a statistical pattern within the LLM. It's not really going out and pulling the paper down from an archive to look at it, right? So it can get confused, or if it doesn't have enough data, it's kind to fill in the gaps just by looking at the statistical.
Back to your point, trust but verify, right? If it doesn't show you or doesn't give you a link and you don't review that paper, maybe you shouldn't cite it.
Yeah, absolutely. That's the dangers of it.
But to that point, right? With all this, back to that trust but verify, the data that goes into these models is super important. This is where you were going on the other paper we were reading.
Yeah, so I think it was it came from Anthropic, right? So they were saying that they don't need a lot of injection of bad or poison documents in your corpus to poison a model, right? You could have like 50 or 100 documents.
100 was on the low end. They tested, I think, with 100, 250, and 500.
Yeah.
And what they found is 100, it was not always consistent in showing the backdoor or showing the fake data they wanted to. At 500, it always did. And even only 250. And to put that in perspective, they were testing models of 600 million parameters to 13 billion parameters. So 600 million is tens of thousands, if not hundreds of thousands of documents. So people previously thought maybe it was a percentage. You had to have 1% or 5% compromised. 250 documents is all it takes to consistently trigger a response in models of those sizes.
So, I was thinking, why is that the case? If he's going off the statistical mean or median or whatever you call it, right? So you have millions of documents being fed in. How can 250 move the needle? So what it looks like is that they're triggering patterns. So they are coming up with, if the prompt has this particular catchphrase, which is very unique, do that that's kind of a poisoning attack. So it's not going to impact the rest of the LLM. It's not going to be always answering different questions.
Right.
But when you trigger that, it's going to respond in a certain way because there's not enough data in the cleaner corpus to be triggered by that phrase itself, right?
True.
So it kind of makes sense, right? If you're just training a small little pattern in there, you're imprinting that idea, right? So,
but there's a lot of ways, and when you think about it, right, remember the way these frontier solutions are built is they start at a certain point and they go scrape the entire internet and they stop. So maybe, they stop if a model comes out in August 1st or October 1st of 2025, maybe they stop scraping in May of 2025.
Right.
And then the rest of it is the training time. So if they're on these cycles, there is a possibility to plant 250 internet posts with that phrase. But then what can you do with it? Can you just make it display certain information, or can you smuggle in instructions? Or
you could smuggle in instruction or make it say things, or what it's up to the creativity of the hacker or the security guy, right? What he's trying to do. Of course, there would be certain safeguards in place, but again, you are controlling the behavior of a model, which itself is a security risk, right? Think of this if you think about open source model, again, you train on a similar corpus. If you inject that in the web, now you have hold of an enterprise grade model, because you may not have those securities in place, right? Because you're thinking it's closed source, because you have pushed that Trojan horse in the beyond the firewall, right, through an open source model. Then you can do various different things, right? This becomes more scary when it goes to agentic, because now the LLMs can do tool call. If they do tool call, then they can actually open a backdoor or divulge information that they shouldn't, right? If you look at a simple LLM, it's just input and output. But as soon as the tool call comes into the picture, then it becomes even more dangerous that way.
Yeah, well, and part of what got me thinking about it is, if it's only 250 documents, that's a very real attack that a persistent actor could do. If you go look at it, it was earlier this year, there was a major issue with a compression library, I believe, for Linux, where someone had spent 2 years becoming the maintainer of that package to go inject a backdoor that would go through. And it was a fairly aggressive process they went through, but they spent years to go try and build this backdoor in that the open source review of the code caught just barely before it went out, or after, as it was going out.
Yeah. So, and again, if you think about this internet, like there is articles, internet is dead. Why is that? Because it's most of it new content generated by LLM itself. So how easy it would be to write those 50 documents using an LLM. So from 50, you go up to 50 million documents, because you could, inject that code pattern, make it look a real document, and you could have a lot of different attack vectors like hidden ASCII codes and stuff like that.
So it does make me wonder one thing: how close in proximity do the documents need to be? And that's something I didn't see covered in their paper. But think about it this way: I'm now going to Reddit, to the various places where user forums where users can go post. Do I have to have them all in one forum, or could I go scatter them across? Think about how hard that would be to go catch. You've got someone building that in, because if they do it right, they're not always putting the same exact post on each one. They're just hiding that
variations. And if you might be able to catch it on Reddit, but maybe not on another unknown unmoderated forum, right? Because for LLM, it's probably considering authenticity or how authoritative that source is. But again, if you are spreading them across various different sources, and it sees this repetitive pattern, then it would learn that very easily, right? And those are very hard to kind of comb them out if you have multiple variations of it. So it's a scary attack for sure. Right?
Well, I mean, and it is, but that's one of the challenges. I think you and I were talking a couple of weeks ago, right? The world when you use LLMs or generative AI right now is very much like It's been described a number of times, like the early 90s, where
Yeah.
there are some security tools there, but there are so many edge cases.
Mhm.
And you've got to really think through, when do you use things? And, we did a panel last week, actually, with some of our friends at Frost Brown Todd, and they were talking about it from the IP perspective. And one of the other things you've got to think about is you've got to think about those security risks, but you've also got to think about, what does this mean from an IP perspective if I'm using these tools to go create the code?
Yeah, absolutely.
Or create the content, right?
Yeah.
So, okay, so there's all these ways to go have the model be risky from the threat perspective, but then there's the who owns the IP, how important is it the ownership of the IP, and what does that impact what I'm doing from a business strategy perspective?
Yeah, that was a very enlightening session, right, where the IP was discussed, because it's really, the fact that we cannot copyright anything, all the codes coming out of the vibe coding world, it's kind of scary too, right? So,
well, and the balance there is, okay, as long as a percentage is human done, and I don't think it's clearly defined on what percentage has to be human done.
Yeah.
But some percentage of that is human done, then there's some arguments you have. But if you just vibe code it away, your prompt isn't copyrightable. It might be a trade secret.
Yeah.
But your code is definitely not copyrightable if it's generated that way. And then you better make sure you're doing a whole bunch of other checking to make sure it's all compatible with all the licenses, and it didn't just got, some AGPL or GPL3 code where you've got to open source your whole project.
Even worse was that if it copies or verbatim copies a block of code from a commercial license, even though you're not including library, now you have opened yourself to an exposure right there, right? So it was very interesting, that whole session, for sure.
I think what it all summarizes, these tools are really, really cool and really, really powerful, but you need to be deliberate in how you're going to apply them to manage your security and your IP and your other risks. They're not a magic bullet.
That's true.
There might be a magic anti-bullet in sometimes, where they do a whole bunch of things you don't expect.
Yeah, true. Yeah. So I think there was another security paper that kind of piqued my interest.
But it kind of answers some of what we were talking about earlier, right?
True.
Which is, how do I prevent my model from being poisoned in some way?
Yeah. It's I don't know if you have an answer whether you can prevent poisoning. That's where I see it, because if you're sourcing your data sources from the internet, for now, at least that's how most of the LLMs are built, using internet curated data.
These guys' argument was, if I have two models and I have that document coming in, before I actually look at that document, or maybe I don't actually look at that document, right? I play a little game of heads up, where I ask the model questions about what is in the data.
Okay, maybe we want to step back and explain the audience which paper we are talking about. So what I think they were saying is that, let's say you have a prompt or a document coming in. Now you don't know if this malicious or not.
Correct.
So you would pass it on to a quarantined LLM, and you will query some predefined
and when they mean
questions.
quarantined, it doesn't have access to tools. Basically, it doesn't really store any data. So if anything bad happens to it, you can blow it away, and you're not harmed.
Yeah, and then you ask a predefined set of questions to kind of infer what's the state of the. It kind of reminds me of the GANs when we were looking at it 5-6 years ago, wherein you have kind of like a creator, right, who's just faking the data, and then distinguishing what is the real data versus
you have a creator and a reviewer.
Correct. And then you're trying to figure out which one, what's real and what's not, right? So kind of that setup, but in the GAN setup, the artificial data generator became better and better and better, and then the differentiator couldn't tell between real data and bad data, right? So that's the GAN setup, but where you are two AI dueling each other.
Yeah, and that was kind of the predecessor for everyone, for what we now look at as transformers or the diffusion type models.
Right. They were very, very popular for a very early.
There's some people using them.
Yeah,
and you still see them in conventional machine learning type applications, because they can be, I think, more reproducible.
Correct. So I think for artificial data generation in a traditional ML world, GANs are really, really useful, especially when you're dealing with data which are very private and you don't want to get to go out, right? So GANs helps quite a bit on that front.
But I think back to the paper we were talking about, the idea was you had this primary LLM and the quarantine LLM. So when a piece of content came in, the quarantine LLM had it, but the primary one had a set of questions. So think about that game heads up, right? The primary LLM doesn't actually know what's in the document, but it can ask questions about it and get answers about it. And the quarantine LLM can't really do anything with the document, but it can go answer those different questions.
Correct. So it's an interesting setup. I don't know how effective it is, but maybe it's good for when you are getting maybe an automated process, even like an
Yeah.
antivirus, but for when you're ingesting a document before you summarize, act on it, run it through the system, make sure it looks good and healthy, and then you pass it on to the main system, right? So, yeah, security is a kind of interesting area. It's always evolving. We
Yeah.
learn new things.
Well, and particularly when you can smuggle in instructions in so many ways, you do have to think about how do you isolate and quarantine so that you've done some kind of sanitization process, whether you use a library in the cloud or you use an approach like this. You're going to have some way to make sure you're not getting unintentional instructions. And this goes back to what we talked about last week. There's still an ultimate challenge of, is the data I'm ingesting true or correct?
Correct. Yeah.
That's the $1 million question of how do you actually do that?
Yeah, I mean, that's one aspect of it. How do you validate that? Whole red teaming comes into that picture, right? The other angle is the privacy. Again, from the forum, right? There was another dimension data scientists often overlook or don't think more thoroughly, or they should be thinking, is around the privacy of the data. What is being used in it, right? So is there a permissible purpose, permissions to even use that data? So
it's not even do they have permission. Right? It's one, what's the minimum amount of data you need?
Yeah.
And when we talk about privacy, we're talking about something that's going to identify a human, right? And that there's a bunch of different range of types of information that can meet that criteria. So do you need it? Okay, how long do you need to keep it? Do you have the ability to remove it and comply with different privacy frameworks? Because in the US, there's one. In Europe, there's a different one. It's one of the important things, I think, is the US is kind of opt out and Europe is kind of opt in.
Right.
And that's a big difference in how you go approach the design. And if you don't tackle that day one, on year 3, that can be really hard to go implement and figure out.
And there are tools available. Even if if you're dealing with PII data, it's always useful to have the best practice in place. Federated learning is one where you would split the data out and not move it to a central location, right? Or let's say you didn't split it, the data is in a different locations, they're privately secure. You send a copy of the model and get trained there, each of them individual and a kind of like a small batches they train. You bring them in, just the model, not the data, and then do some kind of aggregation of the weights across the model, and then resend them back, train, go back and forth. A little bit more expensive compute-wise, network transfer-wise, but it keeps the data stationed at a secure
and you still have
location.
to design your training, though, at that point to make sure you're not really including anything identifiable about that. And that's one of the challenges sometimes is people, it's really hard in this day and age to truly anonymize information.
And I think that question is solved by differential learning, where it would flip some of the answers randomly. So it's very hard, theoretically, to go back and point. For example, movie choices. It's individual, what are the movies they like, right? And you are building a recommendation algorithm based on that. And then in a differential learning, what you would do is you would flip a couple of movies. Okay, you may not like Matrix, or maybe you like Matrix, and they flip the answer randomly. So the model for them, you introduced a noise. The noise is to hide the identity so that you theoretically can't go back. But it's still able to generate. If the noise level is minimum enough, it's still able to generalize and model the movie recommendation for a person of your similar taste and characteristics, right? So that's a differential learning, which is another popular tool as well.
And there's a whole new approach that's been evolving over the last couple of years of confidential computing, where between that and I think the term is homomorphic encryption, where you can go work with the data without ever actually decrypting it.
Yeah,
and that is still new.
Yes.
There was a paper I think we talked about from Google where they were showing that, hey, you can do this with some speed impact, but it's feasible.
Yeah.
I think you'll see more and more of that too, particularly for people who want to do, say, fine tuning of a commercial model, but they don't want the commercial model to have their data.
So for the technical minded people, when you think encryption, is it going to break the statistical relation? It's not. That's what I was kind of looking into as well.
If you use the right type of encryption, right?
Correct.
So when you look at it, what most people think about encryption, they either think about synchronous or they think about public key. So synchronous is like standard, where I've got to give you the key so you can go decrypt
Right.
it.
Yeah.
And I may be using the wrong term because I'm rusty on it. But public key is what we think of as RSA or something like that, where you're using a method to exchange one key that only encrypts things, and there's a different key you keep privately that only decrypts things.
Yeah.
Without both of those keys, you can't read the message, or you can't do the whole process.
So the model would train on encrypted, let's say you have a time series data, it would look very different if you plot them, the actual versus, but the model is able to pick up on the patterns and then do an inference on top of it, right? So, the model would never see the real data, but in inference world, when you are doing, you would probably encrypt it and then pass it through the model, get the results, and then pass it on, right? So it's a very interesting way to do it. Of course, it increases your compute, and you lose some fidelity around the model on if it's done not correctly. So
But that's not any different than any other model training technique, right? So we were talking about last week too about the going from, or maybe it was two podcasts ago, about going from like an FP16 to an FP4 or an FP8.
Yeah, but there are ways, if you're dealing with sensitive data, there are a lot of algorithms which are pretty mature as well to do and not have to push entire PII through a model. And often you won't need the PII data, right? So, I mean, model won't care if what's your social security number. It's more, but if you do pass it, there's a leakage of data, right? So it's
well. And remember, PII in our privacy in a lot of these cases is not just as a social security number, it's can I identify you as an individual?
Correct. It includes location data and all of the other IP. Maybe IP.
Well, it could be IP. It could be any kind of unique identifier. So it could be a cookie. The random GUIDs that they use for cookies.
Right.
If you can eventually tie that back to a person somehow, that's where you run into the challenge in a lot of cases.
Yeah. So it's there are tools out there. It's just the best practices needs to be implemented to make sure everything is safe and secure.
Well, again, there's a certain point where you need to go beyond the hey, we're just doing an experiment and actually architect the solution.
Correct.
And be deliberate in it. What data do I need? Where do I need it? How am I going to leverage it? What do I need the model to do, or what do I need the technology to do, and how do I build those responses? It always starts back with that, because if you don't, you get a system that evolves, and those while in the outside world tend to be very more durable systems. In technology, those tend to be the ones that are brittle, because you don't always know where all the interconnections are, or the things you got to think about that might break.
Yeah, true.
Cool. So any other things you want to talk about while we're here?
Oh, we're going to keep this secret for the next time, right?
Yeah. I don't know if you had any other articles or anything you want to talk about.
No, I think, we were trying to do a demo on a voice one, but we'll do it next time around on that front. But just to kind of touch base, diffusion models, right? So what's the difference between a diffusion model versus the LLM stuff? So LLM, the way I see it is a predictive, one token after another. Diffusion is like, it's going to try to paint the entire picture at the same time. I think
so the way I think about a diffusion model is, if an LLM is, I give it a token and then it goes, what could be next?
Right.
What I see, the way I see diffusion models, they start with static, right? You give it a seed and it generates some random noise, and then it starts to fill in details within the noise, and that noise becomes part of how it structures it.
I think people have tried that even to write an entire essay that way. So you are basically start with a page of noise, and they're trying to flip characters to make it more and more, more cohesive.
That's what the whole company Liquid and their models are. That's where they were taking that different approach, and I think there have been a couple others since then.
Right.
And there's some arguments that going through the diffusion-based model might be faster than some of the transformer-based predictions.
Fast is one way, because you were one shot painting it kind of a thing, right? The other thing I think is cohesiveness, or how the logical flow, since you are keeping the whole context in frame, in memory, or it is able to connect the storylines better without getting too far out, because it randomly flipped a probability dice and complete the storyline went haywire, right? So this keeps you in a global frame, and then you're localizing down, you're adding more details and colors to it.
I'm going to be really curious to test the model, because one of my favorite things to do when I'm testing a new model is to ask it to tell me a story.
All right.
I know you like to ask it, why is the sky blue?
Right.
But I like to ask it to tell me a story and see like how verbose is it, what does it do, how creative is it, and that. And now I'm really curious to see the difference between like GPT OSS versus one of the diffusion models.
Yeah, because if you think about it, humans, even though we speak linearly through an LLM kind of style, we are still creating mental models behind our head, which is like an image or a kind of diffusion like, right? You're filling in more details. You have an idea, you're going down, 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 but you are still keeping the global image of the model, right? The mental model intact, right? So it has a lot of potential. You just need to see if the resource, the right algorithms are in place to make it work or not. So.
Cool. We're probably at a good stopping point. So I appreciate everyone joining us. I forgot at the beginning to ask people to subscribe, drop comments, do the whole media influencer thing, so that we can get better questions or know what people are most interested in us continuing to do as we continue with the podcast. So thank you, Saurabh.
Thank you.